Great, welcome back everybody. Today we'll be learning about how to add expressions. And this lesson is a continuation of our work with combining like terms, because when we add expressions we combine like terms, but our terms are just in different expressions, and I'll show you what that means. So today your objective is to be able to add expressions that represent real-world problems, and you want to be thinking about how properties of operations can be used to add expressions together. Your do now is to go to IXL and click on Scale 7S3. You're going to work for 10 minutes or until the timer goes off, or if you reach a score of 100. I'll let you know when 10 minutes is up, or you'll hear the timer go off, but don't close the tab. So I'm going to underline that. Don't close the tab. I need to see what your score is, and I need to write down your score. It's going to help me know who might need help today during the lesson. So you can press pause, and you can do the do now, and then you can resume the video. So at this point, you have already completed the do now, and you've shown me what your score was. So now what I'm going to do is, sometimes I start lessons off with the simpler problems and I build up to the more difficult problems. Today what I'm doing is I'm going to start with a more difficult problem, and you'll be working on some more simple problems in your classwork. So this is an example of two expressions that are going to be added together. So this is an expression. This is another expression, and they're being added together. You can see that we have some like terms. So we have 11 and 9/10 y and 5 and 7/10, 11 and 9/10 w and 5 and 7/10 w. So those are like terms. We also have 2 and 3/10 x, and then a minus 3 and 8/10 x. Notice that I'm including the subtraction sign. And then we have our like terms, our constants. So there's three groups of like terms here. There's the constants that I just put rectangles around. There's the x terms, and then there's the w terms. So my first step is to write down the problem. Then what we're going to do is we're going to rewrite any subtraction problems as addition problems. And what we're going to do is we're going to put our like terms together. So 11.9w plus 7w. I close the parenthesis. Then I have 2.3x plus negative 3.8x. Then I have negative 16, 15. And so the reason I had us change all of the subtractions to be addition is that once you change them to addition, you can pick up each of the different terms and then put them with their like terms without worrying about if it should be addition or subtraction. So now we're going to solve each of these, or evaluate each of these mini expressions or these groups of like terms. So you might think that this is going to be too tough to do without a calculator, but we just set up the problem. So we do 11 and 9/10 plus 5 7/7. We add them together. To get 17 6/10. 17 6/10 W. Then here, where we are adding a positive and a negative number, so that's kind of like a subtraction problem. So we do 3.8 minus 2.3. We do the bigger number minus the smaller number. And then since the negative number has a bigger absolute value, we know that the answer is going to be negative. The last thing is we have negative 16 plus 15. So you're at negative 16 and you go 15 steps in the positive direction. And so you end at negative 1. If you wanted to, you could rewrite this without the addition symbols. So you can make a subtract 1.5x, subtract 1. Again, that was a more difficult example, so if you were able to follow along with that, good job. If not, just remember this is a more difficult example, and you'll be doing other examples that aren't quite as difficult. Okay, so we're going to continue to add different expressions. It says Delilah signs up for a health club and a rock climbing gym. What expression represents her total fitness cost after M months? So you can see at Rudy's rock climbing gym, there's a $65 initial fee, which means you have to pay $65 just when you sign up, and then it's a $40 fee every month. At the health club, it's an $80 sign-up fee, and then $50 a month for each month. This is what it looks like as a bar diagram. So here's the health club with an $80 sign-up fee and then a $50 monthly fee that goes on month to month. And then this is for the rock climbing club. So a $65 fee and then $40 per month. So when we write an expression for Rudy's, it's $40 per month plus $65. For Ace, it's $50 per month plus $80. And since she's signing up for both, we need to add these together. So you're going to have one parenthesis with 40M plus 65. And another one with 50M plus 80. Now we're going to put our like, there's no subtraction to change, so we can just go right into putting our like terms together. So we have 40M plus 50M. Then we have 65 plus 80. So then we simplify each group of parentheses. We have 40 plus 50, which is 90. And then we have 80 plus 60, 80 plus 65 is 145. And that's as simplified as we can get the expression. Remember that we can't add these two together because this doesn't have an M. So this is a variable term and this is a constant. And constants don't have variables with them. It says Sophia and Ollie each deposit $120 into to open a joint account. A joint account is when the two people are using the account together. They each make monthly deposits as shown. Which expression represents the amount in the account after M months? So up here it shows us that Sophia deposits the $120, and then every month she deposits $150. Ollie deposits the $120 to start, and then deposits $135 every month. So for Sophia, she deposits $120 plus $150 each month. That's why it's being multiplied with M. For Ollie deposits $120 plus $135 per month. All right, in this line, we're going to put our like terms together. So notice how after this box, there's no M. So that means we put 120 there, and this 120 goes here. And notice how this box has an M. So we have 150, and then 130. So now when we combine them together, we have 120 plus 120, which is 240, and 150 plus 135, which is 285M. So we could write 240 plus 285M, or 285M plus 240. All right, we did two normal examples. Now we're going to do another difficult example. So we're going to start by rewriting the problem. Any subtraction, we're going to rewrite as addition. So we have 6y, this becomes plus negative 9z. This becomes plus negative z. Put our like terms together. So we have 6y plus negative 2y, negative 9z, plus negative z, 12 plus 6. Okay, so we do in each parenthesis. So 6y plus negative 2y is kind of like a subtraction problem. So 6 minus 2 is 4. So 4y. Then the plus sign. Negative 9z plus negative z. Remember that this is like a negative 1z. So that makes negative 10z. And 12 plus 6 is 18. You could also write it without the addition symbol. Those are both simplified. Those are both as simplified as you can make them. Last example, it says Cindy spent $125 on ingredients for muffins and $92.40 on ingredients for bagels. Write an expression to represent Cindy's profit for M muffins and B bagels. So for muffins, she sells muffins at $2.40. Each muffin is $2.40. So I'm going to use the variable M to stand for muffins. And she spends $125. So that means I have to subtract $125 because that's how much she spends. Bagels, she sells bagels at $1.80. To use the variable B. And she spends $92.40 on those ingredients. Now she sells both things, so we have to add these two expressions together. There's some subtraction that we need to rewrite, so I'm going to rewrite this as without subtraction. We're going to put our like terms together. So there's no other terms that have an m, so nothing's going to go with the m. Then I'm going to put the bagels, so 1.80 times bagels. There's no other bagels. So now I just have the constants that I can add together. So our final answer is the muffins plus the bagels Going to add these two negative numbers together. So I get negative 217.40. So that's how you add two expressions together that have different variables. The variables don't get combined together because we're talking about two different things. We're talking about muffins and then bagels. So we don't add them together to make something else. Last thing you need to do is the summarizer. You need to have me check and what you're going to do is you're going to go online to the Google form. And you're going to finish that before the end of the class. So let's end the video now. You're going to show me that this packet is finished, and then you're going to go online to the Google form and finish this by the end of class. Finish the Google form by the end of class, or finish it for homework. All right, let's get started.